Alright, what we're graphing is exponentials. There's two types of exponentials. There's growth and decay. Alright, how do you read things? Good, same thing as a graph. You read a graph left to right. So growth means you're doing what? What does growth mean? Going up. Good. So from left to right, a exponential growth function will look like this. It's increasing as you read left to right. And decay is going to be the opposite. It's decreasing as you go from left to right. Now what makes something change directions like growth or decay? That has to do with your base. Now a base is what has the exponent. So for example, in number 2, what's the base? What's the base on number 2? 4. What's the base on number 3? 2. Good. It's with the exponent. So if the base is greater than 1, it's a growth. And if the base is a fraction, it's decay. Again, if the base is greater than 1, it's growth. If it's a fraction, it's decay. Now, to graph exponentials, all you need is 3 points, and they're the exact same every single time. So you don't need a graphing calculator. You don't have to calculate anything. It's the exact same 3 every single time. And here they are. Your x values will always be -1, 0, 1. -1, 0, 1. What are your x values always going to be?
-1, 0.
Good. Now, -1 is always going to be 1 over b. What does b stand for? Base. So like for this one, for the the y value for -1, it'd be 1 over what? 2, the base. Alright, 0 is always going to be 1, and 1 is always going to be just your base. So like for this, our y value would be what? 2. And that's it. That's all you got to do, and then graph those points. So let's make a table for each one. What's my x values? Quick. What is my value for -1 in this one? 1/2 and 2. Good. So 1 over your base, so 1 over 2, 0, and always the base. Go ahead and graph these 3 points. Now make sure on this side of your graph that this line is approaching 0. The reason it approaches 0, can we have negative exponents? No, y'all know this. No negative exponent, so it can't go past 0 right here unless we get to transformations. Last thing is domain and range that we have to identify. Domain is what values? X values, which means how far left your graph's going and how far right. Alright, how far left is our graph going? Not infinity. Negative infinity. How far right is your graph going to go? Positive infinity. Good. Right, as this goes up forever, this is going to go this way forever, right? Right forever? Alright, how low does our graph go? Range talking about y values. It's not going to go past what? 0. Good, we talked about that. No negative exponents. How high is our graph going? Very good. I know I'm going kind of fast. I just have to because today's going to be short. Alright. Can I what now? Yeah, domain is left to right, so left forever, right forever. Range is up and down, so the lowest it's going to go is 0. The highest it's going to go is forever. Alright, next one. Let's skip to number 3. X and Y table first. What's my X values? Alright, my first one is 1 over my base, so it'd be 1/2. The next one would be my base. Now, what is this 1 doing right here, you think? If it was with the X, then it'd be adding to our X values. So it's adding to our what? So we need to add 1 to all of our Y values. So what's 1 plus 1/2? 1.5. 1 plus 1? 2 plus 1? Graph these points. 0, do 2, 1, and 3. Make sure it kind of bottoms out with that last point, just like we did on the first graph. Alright, so domain. How far left? How far right? Now let's look at our range. What does it look like it's approaching now? What y value? 1. Good. It looks like it's bottoming out. I don't even think that's a word. It's leveling out at this y value of 1, correct? And how high is it going? So, look at our original equation. Look at our range. Guess what the range is always going to be? This last number to infinity. Why was this one 0 to infinity? Nothing being added or subtracted, right? And domain, do you think that'll ever change? Nope. It'll always never end on either side. The range depends on what number's being added or subtracted. Yes. Correct. The reason we don't put the brackets for like 1 is because it's not touching 1. It's just approaching it. So it's not actually touching it. Let's do one more. We got time for one more. Oh, we got plenty of time. Okay. Y'all pick one. 2, 5, 10, or 11. Which one? 5. Let's do 10. Alright, x and y. What's my x values? Very good. Alright. My first one, you know, is going to be 1 over your base. Well, what's 1 over 1/2? Hey, you need to sit wherever. What's 1 over 1/2? You don't. 1 divided by 1/2. You don't have to guess. I know y'all have a calculator. 1 divided by 0.5. What is it? No. 2. They're probably the one that used their calculator and not just looking at me thinking I'm going to tell you what it is. Anyways, 0 is going to be what? And what about 1? Good, because it's your base, so it'll be 1/2.
Pretty safe.
So just to point out, look at this table with the 1/2. Look at the one where it was 2. See how the fraction comes down here? Now let's go ahead and graph it. So -1, 2, 0, 1, and 1, 1/2. And just like Cordell said, this one's what? Yes, because it's going down. For real. Thanks. Alright, domain? Nope.
Come on, bro.
Infinity to negative infinity.
Negative infinity.
Always the smallest number first, but also, like, I know it looks like it's going up right here, but domain's talking about left to right, correct? So even though it looks like it's going up, these x values are still what on this side? Negative. Alright, what about range? No, we're not leaving. This is what?
Say the way you jump so hard.
0 to infinity. Again, y'all focus, sorry. There's nothing being added or subtracted, so it's going to be 0 to infinity, okay? Alright, after you do 2, 5, and 11, you can pack up. Try 2, 5, and 11. If you don't finish it, you'll need to finish it for homework because I'm going to check it on Friday. So 2, 5, and 11, you need to go ahead and do that. It's 3 problems. Y'all need more?